it's just hard. So I'll just, whatever. It's the best I got. So I kind of made notes.
I have a question.
Yeah.
If we were to take Calc 2 in college,
Yeah.
all we would learn is the stuff that was on that sheet.
What, like that sheet? Actually, I think they start it. It depends on the college, but a lot of Calc 2 almost starts with integration. Like sometimes Calc 1 is like all derivatives. Yeah.
Well, it's the easiest Calc 1 ever.
Yeah. Yeah. Okay, so sequences and series is something that we decided in pre-calc we weren't going to do in honors. But if you took level 2, you've actually seen a little bit of this before. But that wouldn't be any of you guys.
We did this last year.
Gersbeck did some? Oh, we did this for like a day. We did this for like a day.
Oh, but we did so much of
Like
it.
a month.
Well, it's all horrible tests.
I remember failing a test in
Oh.
like a day and a half
So
to
we're on
memorize
group
these
test
formulas.
and then that
And
question
then
that came up.
gave
That's
us the
why
test.
we didn't do it anymore, because it's just a memorizing of formulas that doesn't have a whole lot of meaning for you in pre-cal until maybe we kind of get to here. But so. Wow,
It
that's
was
nice.
during that was the second period of the past class, like that one day we had the second
Oh
period,
god.
and we had a
That was
1
terrible.
hour test.
She added problems instead of just giving them a
Yeah. And it was too long.
Okay, so I tried to, like, with the first year I taught this, I really was like, I don't know, it just seemed very confusing, and it is very confusing, but we're going to, like, get it to where I think it'll make sense. So, a sequence is literally a list of numbers that follow a pattern. So we're going to look at the same sequence throughout today, and then we'll start looking at different ones and stuff like that. And there are different types of sequences. Do you remember, like, there's arithmetic ones and geometric ones, if you remember it all from pre-cal? And, like, arithmetic just meant literally, if I went 2, and then 4, and then 6, and then 8, that's arithmetic because I'm adding the same term to each consecutive term to get the next term in the sequence. Geometric would be like 2, and then 4, and then 8, and then 16. The difference is I'm multiplying each term by the same thing to get to the next term. So those are your two, like, basic types of sequences, but we're obviously going to go a lot more in depth than that. So I'll kind of try to follow this, and you can fill in. But it's literally a sequence of numbers, so we're going to start out looking at the same one. We're going to look at the sequence 1/2, 1/4, 1/8, 1/16. It's up to you. If you want to write on the paper and then recopy or just put it in your notebook, whatever you want to do.
What?
Why would you write it and then recopy?
Whatever. Do whatever you want. Figure it out.
I don't know.
And these sequences have a way to kind of write them as a whole. So if I was going to write this, what pattern this follows, if you wanted her...
That was terrible.
What?
That was not the chart.
You just throw it in there.
Shh.
Baseball.
Yeah. This particular sequence is 1/2 to the n. So when n equals 1, I get 1/2. When n equals 2, I get 1/4. When n equals 3, I get 1/8. Okay, it's a sequence. Just a list of numbers that follows a pattern. Well, I know it says it on here, but if the limit as, can I use n? As n approaches infinity of that sequence, if that limit equals a number, so not infinity, but if it equals a number, then the series, oh sure, thank you, sequence converges to that number. And just like, what's that?
Isn't that the same thing?
Okay, we'll get there.
Isn't that same just yes? Okay, that's what.
But that it's written down here? Yeah, I'm just trying to have it so that it's there, that's all. Okay, so a sequence is either going to converge to a number, or it's going to diverge. If it diverges, it's one of these three things is happening. If something diverges, that means, so far when we talked about diverging, we talked about that meaning it goes to infinity, but something can diverge and not go to infinity, like I have on here. You can have a sequence that oscillates, like the sequence 1, -1, 1, -1, 1, -1. That doesn't go to infinity, but it also doesn't converge to a single number, so that diverges. Or a sequence could have no pattern at all, but that's like really rare and it doesn't really apply. But whatever, I read it, so we have to. So if we want to know if this sequence diverges or converges, we would take the limit as n approaches infinity of 1 over 2 to the n. And what would you get? As n goes to infinity, what happens? The bottom gets really, really big, so the whole thing goes to 0. So this is why we've been talking about these funky limits to infinity, so that you can apply them to the sequences in series. That because the limit of this sequence goes to 0, this means that the series, or I'm sorry, the sequence converges to 0. Which kind of makes sense, duh. This is kind of is obvious, but you still need stating. That even though my sequence starts at a half, a fourth, an eighth, a 16th, I'm just getting smaller and smaller numbers, right? And eventually, if I went on forever, the idea is I would get to 0. Even though I really wouldn't, I'd get to like 1 over infinity, but that really is 0. So if they asked you if this sequence diverges or converges, you say it converges and it converges to 0. The reason why is because the limit of the sequence equals 0. Okay. The second one. Oh, did I already finish that? Yeah. No, you got most of it already on the paper. So does the sequence, I'm calling the sequence a sub n, of n squared over 2 to the n, does that converge or diverge? So let's get a couple of the numbers first that it equals, because sometimes it's a good idea just to see what the pattern looks like. So this sequence, if it's a sub n, I'm going to usually just start with n being 1. What's the first term going to be if n is 1? 1/2. If n is 2, 1. If n is 3, 9 eighths, right? If n is 4, 30 seconds, right? No, 16ths. So 1. If n is 5,
30 seconds.
so far I see no real good pattern at all. That doesn't mean it's not a sequence, it's a sequence. It doesn't mean it doesn't converge, it still could. It's just bizarre. I start at a half, I go up to 1, I get bigger than 1, I go back to 1, and now I'm less than 1. Now I'm probably going to start following something similar. So if n is 6, I'll have 36 over 64. And now the bigger that n gets, I'm going to start getting smaller and smaller. Thank you. But to be sure, so if we're going to guess, do you think the series converges, or sequence converges or diverges?
Converge.
I think it converges. So let's just look at the limit.
Diverges.
As n approaches infinity, of n squared over 2 to the n. So first of all, knowing what we know about limits, what happens when we plug infinity into the top and bottom?
Infinity.
Infinity over infinity.
L'Hopital.
Whoa, that's a regular rate. Okay, infinity over infinity. So I'm going to do the L'Hopital thing. And we're going to look instead at the limit as n approaches infinity. On the top, 2n. On the bottom, 2 to the n times what?
Natural log of 2.
Natural log of 2. Good. Remember if it was like e to the n, it would just be e to the n, but any base other than e needs a natural log chained on. But when I plug in infinity now, it's still infinity over infinity. Gosh. But my next step is going to solve that. So I'm going to have 2 on the top, and I'm going to have, I don't need to use product rule, I can just have ln2 times 2 to the n times ln2.
So that's 4.
So as n goes to infinity, I have 2 on the top, all the stuff on the bottom. As n goes to infinity though, what's happening to the bottom?
We only have two pods.
What's that? I'm sorry, I didn't hear your question. Say it again.
I said, why don't we have two pods?
Why don't I have two what?
Use product.
Oh, I'm like, I cannot hear you. I don't know why. Because this is a constant. I don't have to. If you use product rule, one of them is going to be like a 0. It's just going to go away. When I have the derivative, this one's going to be 0. So I don't have to use product rule. Sorry, that was like 5 times. So anyway, when I do plug in infinity for n, this gets really, really big. So the bottom gets really, really big. So when the bottom of a fraction is really, really big, the whole thing is 0. So that does converge, and it converges to 0. Okay. It's pretty simple so far, right? If we have a sequence, and we want to know if a sequence diverges or converges, we just look at the limit of the sequence, and whatever the limit goes to, that's what the series converges to, unless it goes to infinity, and therefore the sequence diverges.
So why do we have to write out the first, like, however many?
You didn't really. You don't have to write these out. It was just to take a look at it, to know that kind of like, writing them out doesn't always help you. You could write these out and think, this is divergent, it's like so crazy, but you really got to get the whole big picture. It's 0. Okay, series. Sequences are like pretty JV. We don't really use them that much. Because you're just supposed to like introduce them to get the idea. But series is where it's at. So a series is when you take a sequence and instead of just listing all the numbers, you add them all up. And when you add them all up, you're going to add up an infinite number of numbers, but get a non-infinite result. So one big example of this, I don't think I wrote it down. Think about like a square, like a 1 by 1 square. What's the area of that square? 1, right? But it can be made up of an infinite number of parts. Like if I keep having the square, if I add a half, and I add a quarter, and I add an eighth, and I add a 16th, and I add a 32nd, and I add a 64th, I can do that an infinite number of times, and it eventually will add up to an area of 1. Right? So it's kind of,
because it's not infinitely small, then you have a bunch of zeros. Add all the zeros together.
but they're not infinitely small. So I can add up an infinite amount of parts and still get 1. What's that? It might take me a while.
Do it. 1. At the end.
Okay, so obviously that would take forever, but you get the idea that I can keep having anything. That's why you guys talk about half-life and stuff, right? In like whatever crazy science class, that like it never's actually gone, even though things get. What?
It will eventually be gone because it'll come down to 1.
Will it really? I don't know. But
Theoretically.
the idea that like if I step halfway between here and the door, will I ever make it to the door? If I continue to step halfway,
Yeah, because I'll push
No.
you.
I'll never make it. Because I'll always step halfway, and there'll always be more to step.
Infinitely close.
But I'll get infinitely close. So it's the same idea. I can still break this up an infinite number of times and get 1 as my
That's the
result.
first great step. I want to see this happen.
So a series. A series is the adding up of the infinite terms of a sequence given by the following notation. So the notation goes like this. And we don't always have to go from 1. N usually goes from 1 to infinity, sometimes from 0 to infinity, depending on the series that we're talking about. And let's do the series that we were just looking at. 1 over 2 to the n.
What makes us different from an integral?
I guess that they are very similar, but why?
Because
I guess I don't have a function that represents this, but it was too.
you're not doing all the space in between.
Okay.
Yeah, I don't know. I mean, it's a totally different concept, but it's got that similar component of adding up stuff. So for a series, I'm taking this and I'm still plugging in 1, so I'm getting 1/2, and I'm getting 1/4, and I'm getting 1/8, and I'm adding them up. And I'm trying to figure out what I get when I add all of this stuff up.
Already know it's.
Where you at right
Yeah, I know, but I'm getting there. Yours might be different than mine. I'm on the bottom where it says series.
now? That question is not written.
No, I just wrote it in myself. This is just like a guide. I don't know. It's not like fill in the blanks.
It is from
there are two rules. And I think I might have only put one on your paper, I can't tell. If the limit as n approaches infinity of the series a sub n equals 0, then the series is going to converge. Squeaky. But there's a huge asterisk here.
Huge.
Oh, there's three. If the limit of the series equals 0, then the series is going to converge, but
You do not have the part.
it doesn't necessarily. Uh-oh. I don't know how to spell that. Necessarily converge to that number. Or 2, 0. Okay, so this one's going to be a little bit different. If a series converges, the limit of the series will equal 0. Not just a number, but 0. Specifically, definitely 0. But that's not going to say that this series actually adds up to 0. All it tells us is that if the limit of the series is 0, that tells us that the series converges to some number. Got to go find out what it is. But I don't know what it is. It's not 0. It could be 0, but it's probably not. And conversely, if the limit does not equal 0, then the series diverges. So I only have one choice, and it's different than the sequence. Before, in the sequence one, if the limit equaled a number, the sequence converged to that number. Now, if the limit equals a number that's not 0, it diverges. The only possible way for a series to converge is for its limit to equal 0. So, now we got to look at how do we figure out what the heck a series converges to. So we kind of already know what this is going to converge to, but let's go through and prove it. There's this thing called partial sums. Flip the thing.
Wait, I have a question.
Yeah.
But I'll ask it then, because it's kind of
Okay.
Yeah, we kind of have only 3 minutes of video left.
3 minutes of video left? Alright, sounds good. Okay, a partial sum, this part's written, is the sum of just a few of the beginning terms in a series, and you can tell a lot from a series by what its partial sums do. For example, I'll go back to kind of what this says, but let's look at this particular series first. If we had the series of 1 over 2 to the n, the first partial sum would just be, if I just look at the first term. So if I just plug in 1, I have 1/2. That'd be the first partial sum. The second partial sum comes from finding the first term and the second term and adding them up. So what's 1/2 plus 1/4?
0.75.
Good, 3/4. Yes. The third partial sum comes from taking the first term, the second term, and the third term,
It's gonna get close.
7, 8.
and adding them up and getting me 7/8. And the fourth partial sum, just for giggles,
15/16.
0.9325.
oh, I did. Is 15/16. And if we look at the series of partial sums, meaning 1/4 to 3/4 to 7/8 to 15/16, where's that heading towards? 1. All right, this is adding up, or not adding up, it's getting closer and closer to 1. So to find out what a series converges to, we look at its sequence of partial sums. And if its sequence of partial sums is converging to a number, then we can say the series is converging to that number also.
What?
Right? So,
Can you say that again?
yep. If we take the limit of a series and it equals 0, like we kind of did here, or we know that the limit of this goes to 0 because the bottom gets huge, then we know that the series converges, but we don't know what it converges to. If we now go look at this sequence of partial sums, meaning I look at the first term and then the first 2 added up, then the first 3 added up, then the first 4 added up, first 5, first 6, my results were 1/2, 3/4, 7/8, 15, 16. If these numbers in a sequence, so the sequence of partial sums. This sequence of partial sums is 1/2, comma 3/4, comma 7/8, comma 15 16ths. If this is converging to a single number, then this series will be converging to that specific number. It's gonna stop.
Soon.
Okay. No, we're not totally done.
How do you find it exactly?
We'll get there. So that's why I've written here, if the limit of S sub n is the partial sums, if that limit equals L, then the series converges to that number. Therefore, the series itself, the limit of the series itself equals 0. And if the limit of the partial sums goes to infinity, like if I got 1, 5, 7, or 1, 3, 5, 7, 9, if I got these numbers just getting bigger, it's going to go to infinity in the end. Therefore, my series would diverge, but it wouldn't be converging to that specific number. Okay. That's kind of the general gist. But today's just an introduction. You got to try a bunch of problems. Okay. Here's what you should have gotten out of it. Sequence is just a list of numbers. If the limit of the sequence is 0, then the sequence converges. A series is a sum of a bunch of numbers. If the limit of the series equals 0, it converges. If the limit of the series is infinity, it diverges. But if the limit of the series is 0, we don't know what it converges to. We look at its partial sums, and if we can figure out what the partial sums are getting closer and closer to, that's what the series converges to. Easy, right?